Today the topic is solving linear inequalities. Linear means that it is still x to the first power. We're not going to deal with x to the second or third power until next unit. Inequalities, notice you have less than, greater than signs. The first question I have for you is this a greater than sign or is it a less than sign? Which one? What do you think? Most people would say greater because you're reading from left to right. I want to be clear, it technically is both, and I'll show you. If we write it like this, notice that 4, as we read from left to right, 4 is greater than, it means the larger part before the smaller part. So 4 is greater than 3. But if you read it the other direction, from right to left, we would say 3 is less than 4. You see it written both ways? Okay, and so that's something that we want to keep in mind. You could definitely read and understand it both ways. So you have single inequalities, but these are compound inequalities. Compound inequalities mean that there is more than one. This first one is an example of a conjunction. A conjunction is where your arrows are going to come together. And we solve this inequality by setting up two inequalities. I put the 2 at the middle to make 2 is less than 2x minus 5. And then the second thing I do is I take the middle and I put it with the 7. So 2x minus 5 is less than or equal to 7. So I create two inequalities. I solve for each the same. I add 5 to get 7 is less than 2x. And I divide by 2 to get 7 halves, or 3.5, if you'd like to write it like that, is less than x. I don't like to write it like that where the x is on the right-hand side when it comes to an inequality. Notice how the greater than part is attached to the x. So I'm going to write x greater than 3.5. So those mean the same things. For the next one, I add the 5 to both sides, and I get 2x is less than or equal to 12. And as I divide by 2, I get x is less than or equal to 6. So your solution will be a graph on your assignment and on your test. I will list 3.5 and I will list 6. Does anybody remember, is the circle open or closed on 3.5? Why is it open? Because there's no equal sign. Here we do have an equal sign, so we are closed. Notice this says x is greater than 3.5. That means that the arrow goes in that direction. This says x is less than or equal to 6, so arrow goes in that direction. And as we said, a conjunction, they will come together. The next one is what we call a disjunction. Those will go apart from each other. And notice as it's set up with an or statement in the middle. It's not 2 is less than 2x minus 5 and less than or equal to 7. It's 3x is greater than 9 or negative x minus 1 is less than 5 or greater than 5. I solve them individually. So I divide both sides by 3. I have x greater than 3. Nice and easy. As I solve my other one, I have negative x minus 1 is greater than 5. I choose to add 1 to both sides. Negative x is greater than 6. What do I now do to solve?
Divide by -1.
And when you divide by that -1, when you multiply or divide both sides of an inequality by a negative, you must switch the sign. Sometimes people get tired of different rules that we just make up in math, but I want to be clear. Everybody agrees that 4 is greater than 3, correct? Well, if you multiply both those by -1, you get -4 and you get -3. Notice that if you compare those, that -4 is less than -3, right? So it's that type of logic that we just need to use, and that's why we switch the sign. It does have meaning. Okay, so sometimes when people make this number line, they put the 3 first and the -6 second, because they see them sitting like that. But I should make sure I put the -6 first and the 3 second. Open or close circles? Open circles. And for x less than -6, does the arrow go to the right or to the left? It does go to the left because it says x less than. Very good. X greater than 3, arrow goes off to the right. So there's a little review for you on your compound inequalities. Now let's talk about your absolute values. I'm not going to write out all the rules, but I will show you this one piece, which is if we had an equation of the absolute value of x is equal to 5, what numbers could you plug in for that equation to make it true? What are the solutions to that equation? 5 and -5. So what that tells us, if you just look at this example, that in order to solve an absolute value equation, if you take the absolute value signs off, you have to list both a positive and a negative solution. See that? So notice in this example, I have an absolute value sign. I want to get at the x's. I can't get at the x's unless I take off the absolute value sign. So I take it off and I get 3x minus 3 is equal to 6. But I remember that teacher who told me, hey, if you take off the absolute value, you have to set up how many equations? 2. So you have 3x minus 3 is 6, and 3x minus 3 is -6. Those are your 2. We can solve each one by adding 3 to both sides. 3x is equal to 9. So x is 3. Notice that this isn't an inequality, this is an equation. So that's just the answer. Along with adding 3 to both sides, we get 3x is equal to -3, or x is equal to -1. So we have 2 solutions in that scenario. 2 solutions. We're okay with that? I must have just the absolute value. The -4 and the ×2 are in the way. So what should be my first step here? You could distribute the 2. I would choose in this situation to add the 4 instead. So 2 times the absolute value of x plus 5 is equal to 24. And now you could distribute that 2 like you were talking about, or instead of distributing it, we could, what did we do yesterday? We divided that 2 off. Get the absolute value of x plus 5 is equal to 12. Once you get it so that it's the absolute value, that's where you can then set up your 2 parts. The first part is x plus 5 is equal to 12, and the next part is x plus 5 is equal to -12. I subtract 5 from both sides, x is equal to 7. As I subtract 5 from both sides, x is -17. And those are my 2 solutions. So back when you were in Algebra 1, okay, back in your 8th or 9th grade year, you spent about 3 weeks solving equations, and then you spent about a week and a half to 2 weeks solving inequalities, and then another week doing absolute value stuff. We're doing it all in 3 days, you know what I mean? Because it is review, but we know that we still need to go over some of those nuances. So it is a little bit quick moving, but in terms of linear, hopefully this is some decent review for you. Our last thing we're going to do 2 problems here, and now we're going to put the 2 together. We're going to put absolute values with inequalities. Absolute values with inequalities. And here's one thing you can tell. it's going to be a conjunction, meaning that they will join together like that, if you see a less than sign. Now, I know that there's no less than sign. I know it's less than. But if you think about less than is less than, and tells us that it's going to be a conjunction. Notice how this is less than. So therefore, we know it's going to end up being that arrows coming together. So what do? I take the absolute value signs off, and I get x minus 4 is less than or equal to 6. And my next one is x minus 4. Anybody know what after that? Greater than or equal to negative 6. When we change the sign from 6 to negative 6, we change the inequality as well. Now we can solve both. I add 4. I get x is less or equal to 10. I add 4. X is greater than or equal to negative 2. If you have an inequality, you will show the graph. I want to plot the negative 2 first because it's less than 10. Then I will plot the 10. Open or closed circles? Closed. You can tell from what we talked about that the arrows are going to come together. X is less than 10, greater than 2, negative 2. So it fits with what we said, which is a conjunction. Okay. Now, I want to show you the example of the disjunction, and it is if you see a great or than sign, okay? So I know that it's not the word greater, it's greater, but if you think it's greater, then you know that they are going to be or, and they're going to go apart from each other, okay? They're going to go apart from each other. And I would like to do just one example there, and I'd like to do example D, but for the sake of this problem working out the way I would like it to, can we please start by switching this sign around to a less than or equal to sign? So you may start question D by saying, well, hey, it looks like this is going to be a a less than situation because I see a less than symbol. But you can't make that decision until there's only an absolute value over there. I need to isolate the absolute value. So what am I going to do to both sides to start? I will subtract that 4, and I get negative quantity, absolute value of 2x minus 4 is less than or equal to negative 2. Now to get rid of the negative, I divide by a negative 1. I get the absolute value of 2x minus 4 is greater than or equal to, notice that the sign switches, greater than or equal to positive 2. At this point, we can determine what kind of compound inequality it is. Notice that the symbol at this time is a great or than sign. So we know that they're going to go apart as a disjunction. We have 2x minus 4 is greater than or equal to 2. And we have 2x minus 4 is less than or equal to negative 2. We set up one that's positive, one that's negative with the sign switched. Add our 4 to both sides. 2x is greater than or equal to 6. Add our 4 to both sides. 2x is less than or equal to 2. We divide both sides by 2. We get x is greater than or equal to 3. We divide by 2. X is less than or equal to 1. I plot the 1 and the 3. Open or closed circles?
Closed.
Closed. Are the arrows going to come together or go apart? Well, I see less than 1, so it's this way. I see greater than 3 this way. That matches with what we thought it was going to be a great or, so it's going to be a disjunction going apart. Okay. please take out your homework. You're gonna have time to hopefully finish that today. You guys have done a good job of keeping pace. That means we can mix things up a little bit. So tomorrow we will not have a lesson. We will do an activity. It will be fun. There may be prizes. There will definitely be trash talking. Okay? It may get out of control, but I will be here to supervise. We'll do that. And then on Monday, as I've gotten to know you guys better, I think I have a better seating chart for you. I can seat you around people that are probably work with you. So I will do that as well. Please look at your homework and look at the very first question. I don't have these broken up into individual types of problems. I have them all scattered about. So you tell me, for number 1, is it an inequality or is it an equation? So are you going to have a graph as a solution or just numbers? Just numbers. Are you have 1 solution or 2? 2. Look at number 2. How many inequality signs do you see? It's just 1, isn't there? Since there's just 1 inequality, you don't have 2 different arrows. You're just going to have 1 set of arrows. You don't set up 2 equations. You just set up 1. It's already set up there for you. If you look at number 3, you have absolute value, so obviously there's going to be 2. So I have a mixture of types of problems. That's intentional because people just get used to following a certain pattern all the time. I want you to think about what kind of solution you would get. So please make sure that you check your answers. I would encourage you to check after about every 4 problems. Come up and check to see how you're doing. There are only 12. You very well can get this done before the end of the hour. Tomorrow, again, we'll do an activity. It will be super fun because I only do fun activities. Caitlin laughs at my jokes. You don't always laugh at my jokes. Am I not that funny?
No.
Funny looking? You tell me I'm funny looking?
No.
Is that it? Is it because I don't have hair?
My sister was telling me a story because you used to be her gym, your PM teacher.
Fayed? Who's your sister?
Yeah.
Who is your sister?
Yeah.
Oh my goodness.
And she said you would pull her hair all the time.
Oh, I pull her hair all the time. It's
And
so
then
long.
She said, "Oh, I wish I could do that to you with your bow."
Oh yeah, yeah. Oh yeah. I remember Leah very well. Yep.